Dear students, in the last class we have discussed about the what is a governor and what is the function of a governor, what are the types of governor, and in that the terminology used in the governor, just like height of the governor and lift, sleeve lift, mean equilibrium speed and equilibrium speed of a governor, and what is the difference between a flywheel and the governor. Next, uh, after that, we go for the porter governor. What is the porter governor? How the porter governor will work? Porter governor relation with the speed and the height of the governor. So that is the major thing we need to solve the relation between height of the governor and the speed. So for solving the relation between N and H, there are two methods are there. One is forces or forces resolving. Second one is instantaneous center method. In the last class, the forces by forces resolving in a Porter governor, we have taken the relationship between N and H as N square is equals to small m plus capital M by 2 into 1 plus q by small m into 895 by h. This is the formula what we have received, or simply not a formula. We can say that that is a relation between n and h. Okay. Uh, there, what is meant by q and what is the tan alpha? These are the terms we have learned in the previous class. Now we go for the another method of getting the relation between n and h. So n and h, that is by instantaneous center method. In this method, the equilibrium of forces which are acting on the link BD are to be considered. So BD, that is an, we can say that that is a link. The link we are for instantaneous, we are considering the link BD. Then the instantaneous center, that is I, which is lies at the point of intersection of the PB extension. So there is a PB called a arm. If you extend the PB and draw a horizontal line of extension from the D, which is perpendicular to the spindle, or horizontal means that is perpendicular to the spindle axis, we have to draw a line from D and draw a extension line to the PB. So whenever these two lines are extended and they will contact at a point called I. So that is called a instantaneous center. This instantaneous center, we have to take up the moments about the I. So we are getting the I, about that we have to take up the forces or taking the moments. Moment means force into the perpendicular distance. So from I, if you see in the diagram, that is the uh, weight that is the weight of the ball or dead weight. These two are considered. And at the same time, there is a centrifugal force which is acting by the ball. So for that, for taking the moments about I, the Fc, that is centrifugal force, which is rotating anti-clockwise direction about a central axis or central perpendicular distance Bm. So force into perpendicular distance, that is anti-clockwise direction Fc into Bm, equal to no other anti-clockwise direction forces are there, not be there. Then clockwise, remaining what is the clockwise? The ball acting the weight in the downward, that is with respect to I it is clockwise, and the dead weight is also in the downwards, that is also related with respect to I it is a clockwise. So both the ball weight and dead weights are all related to clockwise direction. So Fc into Bm is equals to weight of the ball small w into a perpendicular distance. For ball it is perpendicular distance, it is Im into, sorry, plus weight of the dead or central load weight W, capital W by 2 into Id is the perpendicular distance. That is equals to Fc equal to small w, we can write it as small m, weight of the, sorry, mass of the ball into G into Im by Bm plus capital M into G, that is dead weight or central load weight capital W equal to capital M into G by 2 into Id by Bm. Then Im by Bm and Id by Bm, this is to be find out. Then Mg is into Im by Bm, we can write simply Id is equals to Md plus Mi or Im plus Md. That is the total we need to find out. Im by Bm plus Md by Bm. We have segregated into uh, two things. That is, finally we get it Mg into Im by Bm plus capital Mg by 2 into Im by Bm plus Md by 2. Then Im by Bm, Im by Bm, we can write it as tan alpha. Okay. In the diagram, in the, let us consider a triangle. There are two triangles are there. BIM, I or IBM. There that is an angle is alpha. MBD, that is one more triangle. So if you see these two triangles, sine by is tan. So Im by Bm is equals to tan alpha, and at the same time Md by Bm we will call it as a tan beta. So substitute these two terms in the equation, we get that is Fc is equals to Mg tan alpha plus capital Mg by 2 into tan alpha plus tan beta. We know that tan beta by tan alpha, that is Q, that is a known thing. So substitute that in the equation. With that, dividing the equations throughout left hand side and right hand side by tan alpha, Fc by tan alpha, or otherwise we can commonly uh, enter the element, that is tan alpha, we can take out. So with that also same thing. So Fc by tan alpha is equals to small mg plus capital Mg by 2 into 1 plus tan beta by tan alpha. We know that tan beta by tan alpha as Q. So substitute that, and Fc as m omega square R. So substitute both the terms, we get m omega square R into tan alpha, that is also known, that is R by H. We just reciprocal it, that is H by R equal to mg plus capital Mg by 2 into 1 plus Q. So by solving this, we get the relation between H with respect to omega. So H is equals to m plus capital M by 2 into 1 plus Q by 2, okay, m into G by omega. So it is not a equal to the speed, that is only related to angular speed. Since angular speed and the normal speeds are both are proportionate, since the formula is omega is equals to 2 pi n by 60, we can directly substitute the omega as 2 pi n by 60. So there also we can get it the previous relation. So previously also we have getted the same relation of h and omega, but again we have solved, again we have simplified the total equation that terms of n and h. Then here also we have to substitute q, and the arm and the links are of both same size or same length. Then the formula becomes q is equals to 1. Then h is equals to small m plus capital M by small m into g by omega square. This is the major formula. The previously by instantaneous and the forces application, the both the formulas are same, since we have delivered the thing for Porter governor only. So for Porter governor, either maybe forces resolving or instantaneous center method, we can solve either by these two methods. Which one is the easier to us, we can solve it. So no other alternative or no other question to solve the Porter governor. Sometimes in the examinations strictly say that derive the equation for speed and height of the governor with respect to instantaneous center method. In a peculiar case, if they ask, we have to solve or we have to derive the equation with that same only. So finally we get it the equation as the same, but the method of approach is maybe the different. By defaultly, most of the cases we can solve it by applying the forces relation only. So in a peculiar case, we can solve it through instantaneous center. Then based on the Porter governor, we are solving two problems today. In the next class, we will go for the remaining problem. Then a Porter governor has an equal arms. So in the question, we have to thoroughly uh, get up the given data. So we have to each and every point we need to take up from the question. So here, what is the condition? It has given Porter governor has equal arms, each 250 mm or long and pivoted on the axis of the rotation. Each ball has a mass of 5 kg. In the question itself, it has given that the equal arms. Arms means the both links and arms. Arms are equal means, see in the diagram, The upper spindle, above the spindle, that means with respect to horizontal, the above are the arms and below are the limbs. Most of the cases, for any problem, they are giving the, we just now we have solved the equation that the limbs and the arms may not be the same. For an exceptional cases, there is a they have given in the question itself that these two are, if these two are equal, we have uh, after finding out the default equation, there we have substituted the both the links and arms are same. So in the problem itself, they are giving that arms and the links are both are same. So that means the length of the arm and links are same means tan alpha and tan beta both are same. So Q is equals to 1. By defaultly, you just remember that the formula. So after getting the formula, it is easier to solve the problem. So for Porter governor, what are the terms we need to know is, firstly we have to remember the formula. What is the formula? That is H is equals to small m plus capital M by 2 into 1 plus Q by small m into G by omega, or 895 by H. That is regarding to n square, n square. So you just replacing the terms n square or H. Both are reversely. So if you place it there, we can find out the n. If you place the n there, we can get it the H. So that is the basic formula. In the basic formula, what is the needs? That means M, that means mass of the ball, and capital M, mass of the dead weight, and Q, G is we know gravitational, that means 9.81, and omega, that means further we need speed, that means capital N we need. And one more thing is Q. For Q value, we need to find out. Q means tan beta by tan alpha. So again, tan alpha means small r by h. Okay. Reversely, we have to proceed. So with that, we can remember the formula in a easier manner. Finally, we get it the information, or we have to find out the n value and h value. That is the final thing we need to find. So for any problem in Porter governor or Proil governor, whatever may be the governor, finally we have to find out the speeds and heights. That is the final thing. Then they're 250 long and pivoted on the axis of the rotation. Each ball mass 5 kg and a mass of center load on the sleeve as 15 kg. So line by line, we have to study the problem and note the given data. Given that the arms and the links are same, so arm is equals to link is equals to same length, that is equals to 250 Okay. Then mass of ball small m is equals to 5 kg, capital M is equals to 15 kg. Then again, the radius of rotation of the ball is 150 Radius of rotation means R, that is equals to 150 Next, and the governor begins to lift to 200 when the governor is at maximum speed. So what they are given that when the governor begins to lift, so when the lifting is started, at that time they are maintaining a speed of 115. The lift reaches to the maximum position. It reaches to the maximum position. The speed of the governor is also reaches to the maximum speed, that is 200 So there is a sentence while we are reading, we have to just clarify about the sentences. So that is 150 when the governor begins to lift. So while it begins to lift, the speed is 150. That is R1 is equals to 150, and it reaches to the maximum speed. R2 is equals to 200 mm. And the lift, find the minimum and speeds and range of the speed of the governor. What we are finding here, only the maximum speed and minimum speed. There itself, the problem itself, they have given the speed variation is there. That is R1 is there, R2 is there. R1 means for lower speeds, R2 is maximum speed. Here what they are asking is, what is the minimum speed and maximum speed? That is the thing we need to find out. That means N1 and N2. And what is the range? That means the difference between N1 and N2. So with that we can get it the information. So that is, we just draw a diagram for a Porter governor. We have to given the line diagram only. It is enough to for constructing the model. So Porter governor for line diagram, that is this PBD. PB is the arm and BD is the link. But these two are same. So we have to join these two in a vertical spindle of same axis. So the BP is a arm and BD is a link. Both are of same. So 250 mm and 250 mm. And the angles also both are same. That is the thing we need to write it. And mass capital M is equals to 15 kg, small m. Okay. Then what is the minimum position and maximum position? So with the minimum position and maximum position only, we can find out the minimum speeds and maximum speeds. So according to that, we have to construct two diagrams. One is for N1, that is the height is, in both the cases, the height may not be same. So according to the height of the governor, the speed may vary. We know the relation. So with that, one is for maximum speed, another one is for minimum speed. So the diagram will be like this. The B to G, see here, that is the minimum or maximum speeds. Okay, this is the diagram for that. And then what is the radius of, depending on the radius. So how to identify the speed of rotation? You know the relation as, when the speed is increases, the height to be decreases. When the speed is increases, the height to be decreases. If you see, compare these two diagrams, the H1 is more than the H2, and at the same time you just see the speeds, that is 200 for H2, and this is, that is maximum speed. For maximum speed, the height is not be the limited. So the maximum speed where R1 the minimum speed when R1 is equals to Bg is equals to 0.15. Bg is equals to 0.15 meter. That is the radius of rotation. Let N1 be the minimum speed, and we can see from the diagram that we have to find the height of the governor. It is just like a triangular BPG. So height PG is equals to H1 is equals to root of PB square minus BG square. Since the hypotenuse is equals to adjacent and the altitude. So with that, we have to solve the H1 is equals to 0.2 meters. Next, we know that the relation as speed n1 square is equals to small m plus capital M by small m into 895 by h1. That is equals to small m, it is 5 kg plus capital M 15 kg by small m 5 kg into 895 by h1. h1 is nothing but 0.2. That is finally n1 square, that is minimum speed for the height as 17,900. Then finally n is equals to approximately 134 rpm. It is a speed of rotation. The maximum speeds with respect to R2, that is Bg is equals to 0.2 meter. That means 200 mm. Let N2 be the maximum speed from the same what we discussed for minimum. The same thing is to be repeated here also. From the figure, the height of the governor H2 is equals to Pg equal to hypotenuse Pb square minus Bg square. There is a square root of. So finally it is a 0.15. We know that N2 square is equals to small m plus capital M by M into 895 by H2. Probably the N2 as 155 rpm. So for speed it is N2. Then range of speed is nothing but the difference between the speeds N2 minus N1 or N1 minus N2. That is which one is the maximum speed minus minimum speed. Here N2 is the maximum speed minus N1 is the minimum speed. N2 minus N1 is equals to 155 minus 134. So approximately 20 rpm is the uh, range of speed. Then again consider one more problem. If you solve it, the same model, but only the difference is if the friction at the sleeve is equilibrium to 20 Newton. So what is the problem? We are taking the same as the arms of the porter governor are each of 250 mm long and pivoted on the governor axis. And the mass of the each ball is 5 kg and the mass of the central of the sleeve, that is 30 kg. So both are same. Arm and length are of same length, and mass of the ball is 5 and mass of central is 30 kg, and the radius of the rotation of the balls is 150 mm. When the sleeve begins to raise in the previously also the same type of uh, information has given for solving the problem. There that is 215 kg as a sleeve. Here that is 30 kg, and the radius of rotations are 150 and 200 both for maximum. Determine the speed range. Up to now that is clear. If the friction at the sleeve is equivalent, if the friction at the sleeve is equivalent of 20 Newton of load at the sleeve, determine how the speed range is modified. In addition to the central load, there is a frictional at the sleeve. So from the diagram, we have to draw a diagram that the same for minimum speed and maximum speed, since we need the range of speed. So draw a diagram for that. Given data, that is BP and BD equal to 250 mm and M small m 5 kg, capital M 30 kg. R1 is equals to 150 mm and R2 is equals to 200 mm. Uh, First of all, find the minimum and maximum speeds of the governor. Let N1 be the speed of the governor, that is minimum, N2 be the speed of the governor as maximum. Then the speed N1 be the minimum when R1 is equals to 150 mm. Then from the figure that we find the height of the governor as H1 is equals to PG, that is equals to hypotenuse to the adjacent. So the final relation we get it as 0.2 meter, and from there n1 square is to be find out. N1 square is equals to small n plus capital M by M into 895 by H1. Since the Q value is as 1, with that the formula is simplified to like this. So 5 plus 30 by 5 into 895 by H, that is 0.2 equal to 31. Go for 31,325 and N1 is equals to 177 RPM. And similarly, go for the maximum speeds. N2 be the maximum speed of rotation of the governor. We know that the height, that is H2, based on that the formula hypotenuse to adjacent, we get it as 0.15 meter. And the same thing we need to substitute in the uh, speed equation, that is capital M plus small m by m into 895 by H2. We get it as N2 as 204. Then the range is difference is N2 minus N1. Up to there, the problem of solving is similar. But there is a condition that the speed range, that is friction is 0. Here now we are implementing the friction. The speed range when the friction at the sleeve is equivalent of 20 Newton of load, that is F is equals to 20 Newton when we are considering for the speed range. So due to the friction, there may be a loss. So when the sleeve moves downward, the frictional force will acting in the upward direction, and the minimum speed is given by n1 square is equals to small m plus capital M. That means uh, small m plus capital M. There the friction is acting means the dead weight center or sleeve central only. So there we have to subtract the frictional. Friction is nothing but the loss only. So we have to subtract it from the the dead weight center. So small m plus capital M minus F by small m. That is the only the difference. So we have to subtract the weight or subtract the mass. So here the newtons it is there. Actually it is in the newtons. F is nothing but the newtons. So we have to substitute it in as a forces. So what is a m is called a mass, but we need to convert into a force, that is called a weight. So we have to multiply all the terms with g, or otherwise we can divide the f by g. So small m plus capital M minus capital F by g by small m, or otherwise small mg plus capital Mg minus capital F by small mg into 895 by h1 for minimum speeds. If it is maximum speeds mean h2. So by substituting that, we can get it the minimum speed as 29,500 rpm as n2 n1 square. Approximately by routing off, that is 210, sorry, 172 be the minimum speed. And also in the same way, we have to uh, get it the information for maximum speeds. When the sleeve moves upwards, the frictional force which is acting downwards and the maximum speed is given up. So when the frictional force is acting in the downwards, already the sleeve weight is also acting in the downwards. If you see in the diagram, the capital Mg by 2 is already moving in the downward direction, so that the additional force or the additional frictional force is added to move the maximum speed for gaining up. So n2 square is equals to small mg plus capital Mg plus F by small mg into 895 by h2. There the h2 value we know. So finally we get the n2 square as 44,200. Then finally n2 is equals to 210 rpm. Then the range of speed is 210 minus 172. Finally that is a 38 rpm. So by the application of the frictional force on the sleeve, the range of speed as 38 rpm, and without application of the frictional force, the range is 27.4 rpm. So how that much of speed range will be there. So approximately 27 and 38, approximately that is a 10 rpm of difference without applying of frictional and neglecting the friction. How much of that is a speed range. So with that, the Porter governor and the Porter governor problem solving, that we have discussed in the today's class. The next class we will go for the another type of governor. Okay, thank you.